Next, we're going to learn how to name alkenes. And the rules are similar to what we've learned before with alkanes. There's just a few subtle differences to deal with the double bond. And the thing you want to keep in mind when doing this is the double bond is our parent functional group. So it's really what we're giving priority to for the parent ending and for the numbering. So first step, find your longest continuous carbon chain that contains both carbons of the alkene. This is crucial. You have to capture both carbons of the double bond in the parent chain. From there, number from the end that gives the double bond the lowest numbers. When you come up with the parent name, you want to change your ending, ANE, to ENE to specify that it's an alkene. And then finally, you assemble the name. So the general format for the name will be, if applicable, you include the E or Z configuration. From there, you write the substituents. Then you need to tell the reader where in that parent chain the alkene's at. It could start at carbon 1, it could start at carbon 4. The reader has to know. So you need to include the alkene carbon number. And then your parent. And take note that this alkene carbon number is actually the first carbon of the double bond, because the double bond is always going to have two numbers associated with it when you number the chain. It's the first, or maybe I should say the lowest number. Okay, so let me show you a couple of examples. First, in terms of just finding the longest carbon chain. So you'll see I've drawn this molecule twice. And it's very tempting to want to say this is the parent chain, because that has 7 carbons in it, and that is the longest carbon chain in the molecule. The problem is you've left out highlighting this carbon of the double bond. So that's the wrong parent. Instead, our longest carbon chain that captures both carbons of the double bond is this. Then when we number this, number up through 6, and this as the parent chain would be hexene. But you also want to tell the reader where that double bond is located in the hexene chain. So we'd write 1-hexene. There's also a newer system that can be used in the name where you would write it as hex-1ene. Either of those parents, writing it either way is perfectly valid. So if we assemble the name for this, we don't have an E or Z configuration. Why is that? Well, on carbon 1, we have 2 hydrogen, 2 of the same thing, so no stereoisomers. So we just deal with our substituents, and we have 2-ethyl, we have 3-methyl. We put those alphabetically as always, and then our parent name, 1-hexene. Let's see if we can name this one. In fact, you might want to pause the video here and just see if you can name it on your own, and then you can watch the solution to see if you get it right. The first thing I'm going to do is assign the E or Z configuration. And I'll also draw in the implied hydrogen here, just so we know we have it. Here is the plane of the double bond. It's kind of running through there. And then if we prioritize our groups, on the left alkene carbon, I'm just going to write the ones. So bromine's priority 1, the carbon here is priority 2. On the other alkene carbon, the carbon's priority 1, the hydrogen's priority 2. So here the priority 1 groups are on the same side. So this is the Z alkene. All right, so now for the IUPAC name, we need to find our parent chain and highlight it. Well, our longest carbon chain is going to start down here. We'll capture both carbons of the double bond. We'll get to here. All right, now be careful. You might be tempted just to want to go out and capture the rest of the horizontal chain, but if we go up, you can get 2 more carbons, which is better. All right, now from here, another common mistake is to fall back on your alkene naming rules, or I'm sorry, your alkane naming rules, and start numbering here because you would get your first substituent at carbon 2 versus your first substituent at carbon 3. Well, with alkenes, that rules out the window. Our priority is to get the double bond, the lowest possible numbering, and that's going to be numbering from this side. That puts the double bond at carbon 3. This is an 8 carbon chain, so it's not octane, but it's octene. Right. In this one, let's use the newer system, and we'll write it as oct3ene, so you can tell the reader exactly where that double bond starts. In terms of substituents, we have a 7-methyl, we have a 6-methyl, and a 3-bromo. Right, well, I think we're ready to assemble the name. Let's start with the configuration, which is Z. Sometimes people will put that in parentheses. If it's just one alkene in the molecule, you really don't need to. But if you had more than one, let's say you had a double bond at carbons 2, which might be Z, and carbon 5, which might be E, then you would put it in parentheses and include the numbers. But if there's just one, there's no ambiguity there, so you don't need to go to that extreme. So we start with the Z. Now we put our substituents down alphabetically, 3-bromo. We'll combine the methyls, 6,7-dimethyl. And the parent, oct3ene. Or you could have written it as 3-octene. Either is perfectly fine. The last thing I want to show you how to do with acyclic alkenes is just naming something with multiple double bonds. And the way you want to think about this is if you have 2 double bonds, that's considered a diene. 3 would be a triene. 4 would be a tetraene. That's about as far as we're going to get. So let's say you had this. Okay, so in this one, our longest carbon chain is just the entire carbon chain of the molecule. That's fairly easy. If we number it, 5 carbons. Well, we have double bonds at carbons 1 and 3. So we'd say 1, 3, penta, and since we have 2 in this case, pentadiene. To make it sound better when we have more than one double bond, we keep this A. And to be entirely correct with this name, we should probably also include the fact that the alkene at carbon 3 has the E configuration, so you would put that in front of the name. You don't need to designate its number. It's okay if you write 3E, but it's not necessary because it's the only double bond that could have a stereoisomer. This one can't because it has 2 hydrogen on it.